Okay, in this session we will discuss AHP, or stands for Analytical Hierarchy Process. So this tools or this method is part of multi-criteria decision analysis methods, which arguably one of the most popular one. There are several things that we would like to discuss. We will start from the um, definition or some kind of introduction to AHP, and then we will discuss again a little bit why this tools is necessary, and then we will discuss about the procedure on um, mm, conducting AHP. So basically this is based on a book that I will show you later, the reference, and at the end of the session there is a link to a video that can show you how to use one software called Super Decision to do the HP. We are still on the course outcome 1, which is analyze the various MCDM methods. We will start from the some kind of initial introduction to HP. So basically, these words were based on the books that we will use as also as the main reference for the discussion in this slide, which is written by Professor Enrique Mu and uh, Milagros Pereira Royas. So the book is entitled Practical Decision Making, an Introduction to AHP Using Super Decisions. So basically, why we need a tools or a methods to this like this AHP methods. So this is based on the necessary that we have where human beings is always need to make decisions, and decision making process, um, it is a rational process. It's just, however, it is become like the way we make decision is sometimes is not rational. So there is a lot of bias might involve in our decision making. Okay, so there is a need to adopt a method, okay, which is straightforward or easy to understand, effective, which is like it will give you a consistent results based on the criteria and interest that is known, or information that is being provided. And then lastly, this book using the term safe, which means that the methods that we are using is proven. Proven means already being used, already being experimented by several studies, and it's proven to be successfully giving you results. And AHP, or analytic hierarchical process, um, somehow meets all the requirements that is mentioned earlier. Well, it's since first introduced by Professor Thomas Sati. Now it has been adopted and used by a large number of institutions all over the world. Okay, first of all, we will discuss about there is a needs for decision making methods. Okay, so basically, in as a managerial levels, okay, in a company as a managerial level, you can we can categorize there is three type of roles of managers: interpersonal roles, okay, informational roles, and decisional roles. Okay, so specifically to decisional roles, a manager should be a effective decision maker, which effective decision making is a fundamental skills for a manager. In the end, why it is important? Because at the end of the day, the decision that you make, which right, can be wrong, this will make the firm whether it will going to be succeed or fail. And well, actually, decision-making models at individual levels is already have been proposed before by Simon in 1960 in his books, The New Science of Management Decision. It defines that decision-making is a process that comprises of steps such as you should have the intelligence, knowledge about the decision that you need to make, and then you make the design of the decision, which option are available, and then selection of those options, then implement the decisions. Okay? And so basically several questions are being asked, like what is the decision are going to be made, okay, what is the options, and then what is the option means like what alternative that we can evaluate among to make among those decisions. And then we move to select from these alternatives or options by applying, okay, this option have this criteria. Okay, we select based on the criteria that we want. We evaluate based on several criteria. And then based on those alternatives, they will have the attributes that relate to the criteria that we have, right? So these are the selection process. Then finally, we will able to implement based on the assessment of those of each alternatives based on the criteria that we have, and then they will have the attributes that we want to assess. Well, but however, yeah, the human decision is not always rational, like mentioned earlier. It much influenced by cognitive bias, so our previous experience or peer from information from the peer and so on. So there is a need for decision-making methods that can help minimize this bias and increase the likelihood of making effective decisions. Okay, so other than AHP, well, perhaps previously we also already learned like we can use Go programming to be more exact. However, those approach may not be practical due to limitation of the decision maker on using the tools. Another simpler method, but we haven't discussed in the class, is like, okay, we can make a list about pros and cons of the decision that we made, and then based on all the alternative, all the option that we can choose, we can compare the pros and cons. Well, perhaps it's the best method for the decision making. However, when we use this pro and cons, this simple method can be greatly improved. It means that when you have pros and cons, the cognitive bias is still high, and it can be improved by sometimes pro and cons is really depends on someone's intuition to make the decision. So, and then the process is become complicated when several number of alternative or several number of options, and each option has their attributes or factors, and this will make the things complicated. So that's why a better method is needed. There were several methods for decision making, like we discussed earlier. Go programmings, or the one that we will discuss later, like TOPSIS or electric. It will need some specific training in each field, like economics OR and statistic probability and so on. And in 1980, Professor Thomas Sati proposed one of the now become the popular decision-making methods, so-called AHP. So it's basically provide a structured decision hierarchy. This is to reduce the complexity, and then it can show the relationship between the objective with each criteria, of course. Objective, alternative has uh, uh, sorry, the objective is to decide what kind of things we want to achieve, and then to achieve this objective we have several criteria. Okay, we will discuss about this later. And then this criteria will have several possible alternatives that we can choose. Okay, so one of the biggest advantages of this method is that it allows the inclusion of intangibles, like intangible knowledge, experience, subjective preference, and intuitions in such as a logical and structural way, so that you will not lose that part that become intuition, that sometimes said to be very helpful to help the decision making process, especially in managerial level. Okay, first let's discuss the basic theory of AHP. So in order to use AHP for decision making, you need to follow several of these steps. First, you need to develop a hierarchy, and a hierarchy would consist of goal, criteria, and alternatives. So basically, what is goals? Goals is one thing that you would like to achieve. Okay, you would like to achieve from your decision. Let's take example about selecting the best supplier, for example, supplier for your the products that you need to produce things in your company, for example, suppliers. And then in order to supply these products, you will set the criteria. What kind of good suppliers will be the best that you want to to represent the best suppliers that you would like to select. Okay. First, okay, maybe I want to see whether they can give a criteria, so-called the price. Okay. Normally, the cheaper the price of the parts that they supply, the better. However, you're not only considering the price, because price comparison only already shown that sometimes the total owning cost, okay, just as bad, is not represented only based on the initial purchasing cost. Okay, perhaps more considerate decision will also see from the, for example, the quality of the products that they um, that they will give it to you. But quality is a subjective. So sometimes quality of a products is not consist on based on the build quality, but also maybe like the features of the products, and then that they supply, also the 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 service that provided by the suppliers, that will also determine the quality of this suppliers. Okay, and another one is like the on-time delivery, because sometimes you need to see whether this supplier is often to be late give you the products that you need, because it will have significant impact sometimes to your manufacturing process when you have the suppliers that is not on time. Okay, so these are some things that we call criteria. And then this criteria is for what? For choosing among alternatives. Alternative is what? Alternative is like basically the company that you choose as the supplier for this example. For example, okay, supplier number one located, for example, in the nearby city, but they can give you a good on-time delivery. However, the price may be higher and the quality, let's say so something like that. Or supplier number two that maybe have the lowest price, however they're quite far from your city, and their quality is actually, yeah, also so maybe like that. And supplier number three maybe that have uh, the highest quality, however the price is in the mid-range and the on-time delivery is okay, something like that. So these are the hierarchy that you need to process in order to use AHP. Okay, and then you will assess relative weight of criteria. It means what? It means that among these criteria, okay, criteria 1, criteria 2, criteria 3, you will have the relative priority. For example, oh, one decision maker may have tendency to uh, give more weight to the price compared to the quality, okay, or price over quality and time, or the other way. Oh, I have the subjective priority on weight should be weight of quality should be higher than the price and on-time delivery. This is called assessing relative weight of the criteria. And then based on this, you will have which criteria have the higher wage, and then you will need to assess the alternative. Uh, Assess the alternative. Okay, this one. 3. Based on the relative priority with respect to the criteria. Okay, so for example, okay, based on the price, okay, the price, which one should be have the highest priority? For example, oh, like I mentioned earlier, the price of the first uh, alternative, which is supplier 1, is much better than the supplier 2 and 3. Okay, and then you need to assess in the second criteria. Oh, based on quality, which one? Third will be better than 1 and 2, something like that. And then finally, based on independent assessment of each criteria for each supplier, you will calculate the overall priorities. Okay, so you will have the end results there. Okay, we will explain the basic steps of this AHP hierarchy, and we'll guide you every step of it with examples that hopefully make it clear. Okay, now we will go to the first step, which is development of the hierarchy. Take example of a decision to purchase a new car. So in a decision to purchase a new car, okay, the goals, of course, choose the best car that's suitable for you as a decision maker. Okay, and let's say that our purchase will be based on criteria such as cost. This is criteria 1, comfort, and safety of the car. Of course, these criteria normally will be based on criteria that is it's not easy to be quantified. Okay, the cost perhaps is easier to quantify. Okay, because one price is not, more expensive than the others. However, like previous example, comparison based on cost only is not always determine the decision making process. So let's say we will evaluate uh, several alternatives based on this, and let's assume that we have, to make it simple, two options for the car. This one, first car, and then the other one, the second car. Yeah, I'm not mentioning any brands or any particular type of car. It's just for the example purpose. We put two picture of a very famous car manufacturer here in Indonesia. So to analyze the decision of purchasing a car, we need to when we use AHP, we should follow the next step. After we have this hierarchy, we develop a model for the decision. We derive the priority or weights for each criteria, in which it's here, compare each criteria. We will derive local priorities. Let's say for cost, we will compare car 1 and car 2. Which one will be more preference by the decision maker? Okay, and then next we will move to comfort. Yeah, compare car 1, car 2, see which one is getting more priority or more preferred by the decision maker. Okay, so based on that, several local priority comparison, we will derive the overall priority, or we call it model synthesis. And then in order to uh, make sure that your decision is how to say is quite robust, we will also need to perform sensitivity analysis on the decision that you made, and then based on those, then we can make a final decision. After we have the hierarchical models ready, we can move to the next step, which is called assessing the criteria relative importance. So based on the decision maker assessment, each criteria should be compared, and then they need to show which one is more important to the others. So this second step in the AHP process is to derive the relative priority weight or for the criteria. And in order to compare this criteria, we will first require to know the grading, or give the weight based on the based on this scale or numerical scale, which developed by Professor Sati, as shown in here, table 1. Okay, so table 1. how could we use this? Okay, yeah, we can show the examples in figure 3. This show the pairwise comparison matrix in which we use for comparison among the same criteria. For example, criteria 1, criteria 2 should be equals to 1 because they are the same criteria. Both criteria are equally important. However, for a different criteria, let's say criteria 1 and criteria 2, you will see, okay, you have criteria 1 and criteria 2. You need to judge which one is more important to the other one. Let's say in this case, okay, criteria 2 is more important for some decision maker. How important is that is? It is moderately more important, strongly more important, very strong more important, or extremely strong more important. Okay, so which one is it? Let's say in this case they say that okay, it is strongly more important. So criteria 2 is strongly more important than criteria 1. So you give 5 in criteria 2, and then the reciprocal value, which is 1 per 5, as the in this column, which compare 1 and 2. Here 2 and 1 is 5, something like that. Okay, so yeah, so basically you need to only give a grading or the assessment in the diagonal part of this. For example, this one is not necessary, this part, the one that is not being colored, you don't have to put any assessment. You just need to assess here the one that is shaded in gray. C1 and C2, 1 per 5 means that this one is more important, strongly more important. 5 here, 1 per 5 here. If it is equally important, so it's 1 here. Let's see, like 1 and 3, criteria 1 and criteria 3 is equally important, so you put 1 here. Okay, 1, so here should be 1 as well. Yeah, something like that. And then 2 and 3, okay, let's say here they said 2 is more moderately more important, so this one 1 divided by 3, this one should be 3 here. Okay. So only the comparison that we put on the upper part of the matrix or the shaded area, like I explained earlier. And then another important consideration is when completing the comparison matrix is you need to respect the transitivity rules. It means like what? It means like when you have more than 2 criteria, okay, you should see that okay, you mentioned that criteria, let's say here 2 is more important than 3, okay, and then let's say for this example 2 is more important than 1. Sorry, 2 is more important than 1, 2 is more important than 3. So later on you need to check whether this this comparison is also consistent with the another comparison that you made. Okay, after the we know the concept of how derive priority weights for each criteria. Now let's go back to the example in the first place that we explained earlier about the buying car decisions. Well, it is clear that when we buy car or in other decisions, not all criteria are equally important in a given time for different subjects. Different criteria means different importance. For example, here, when we compare the cost and comforts, let's say for this example, we show that cost is very strongly more important than comfort. So we put 7 here, and then we put 1 divided by 7 here. And then next, when we compare cost compared to safety, okay, here let's say, okay, cost is moderately more important than safety, so they put 3 here, and then put 1 divided by 3. Next is to compare comfort and safety. Here, the decision maker saying that, okay, safety is moderately more important, so you put 1 divided by 3 and then put 3 here. That will be the first steps that we will do in the deriving the priority weight for each criteria. And these steps normally called pairwise comparison on the criteria. Okay, pairwise comparison on the criteria. And the number about 1, 3, 7, 9 is based on the numerical scales that we mentioned earlier in table 1. Okay, so after that, what should we do next? We actually at the end of the comparison, we will find the calculation of weight priority in each criteria. In order to do that, to calculate the overall priority or weights for the criteria, there are two methods available, the exact method and the approximate method. For simplification purpose, here we will use the approximate method. Okay. The approximate method, however, you need to keep in mind that this method provides valid comparisons to the overall weights only when the comparison metric is having the very low inconsistency. We talked about inconsistency earlier, and now you can see that the example of inconsistency is that, let's say, okay, in a different case, that you are saying that, okay, cost is more important than comfort, and you say that comfort is more important than safety. Later on, you cannot say that, okay, safety is more important than cost, because this doesn't make sense or doesn't consistent. Okay, so this is example of consistency. Okay, or the other way around, maybe it's more makes sense for some people, to make it make more sense. When you say safety is more important than comfort, and then you said comfort is more important than cost, okay, later on if you say that, I think cost is more important than safety, it doesn't make sense, because earlier you already said that this is the relationship, so it's not consistent. Okay, so for this one, it is consistent because it doesn't looks like this. Okay, next, we use approximation method to calculate the weight of the priority. Okay, in order to do this, first we will calculate the normalized matrix of the judgment or assessment that we already create. Okay, now to do the normalization, first you need to sum all the columns. Okay, sum all of the column here. Okay, column, this value is based on what? Based on this one, actually the same one. They basically just like make it two decimals. 1.0007870003 is 300. This one divided by 7 is 0.143, right? Equal. And then 1 divided by 3 is 0.333. Yeah, make it decimal for all of it. And then you sum all of this. So 1.0 plus 0.143 plus 0.333 is equal to this one. This is also the same. Okay. And then to normalize it, you divide all of this value, okay, to the sum of the column. Okay, and then you will get this one. For example, this 0.661 is equal to 1.00 divided by 1.476. And then this one 0.637 is equal to 7 divided by 11.000. Okay, so here do all of this the same, then you will get this called normalized matrix. Okay, the last step to generate the priority weight is based on the normalized matrix here. You find the average. It means what? That this comfort's normalized value plus cost normalized value plus comfort normalized value plus safety normalized value divided by 3. Then you get the average, right? So this will be used as the uh, priority weights of each criteria. This basically means that the higher the weights, it means you will prioritize those criteria more than the others. Okay, for example, here the one that have the most priority is this one, cost, and then second one is safety, and then the third one is the comfort. And then you put it back to the original column here as the priority weights. Okay, previously we said that to use the approximation method for the priority weight, you need to have a consistent judgment. It means that any comparison matrix that fulfill the reciprocity and transitivity rules is said to be consistent. Okay, so in order to calculate this, the you can calculate by the you need to calculate the consistency index. Okay, and then how do you calculate the consistency index? It will be based on the lambda max. Okay, based on this formula number 1, which proposed by Professor Thomas Hatti. And lambda max, what is that? It's a matrix maximal eigenvalue. And how do you calculate this? There is you can use the software to get this value of consistency index, or you can calculate it manually. Later I will show you one links that you can use to calculate the consistency index manually. Okay, and what is n? N is the number of factors, or the number of criteria that is being considered. And then based on this consistency index, you can calculate the consistency ratio, okay, which will based on the formula number 2 there, in which here that you need to have the comparison with the division with the of that consistency index with random index, which is tables based on the consistency randomly generated metric, in which that the number is already defined. For example, if you have a criteria equal 3, the number of RE will be 0.58. But what about less than 3? Basically, you can only compare 2, right? 1 and 2. So for 1, no, you don't need to make a AHP. You just directly straightforward choose that one. However, if you have 2, your comparison will always be consistent. So the table is start from 3 here. Okay, and then after you calculate this CR, the number of CR less than 10%, it means that your inconsistency is less than 10%. So this is the threshold to showing that your comparison is consistent. And for manual calculation of this consistency index, you can go to the links and see the tutorial provided by Dr. Khalid Ahmad Khan in this link. Okay. This part we will see how to check the consistency of the assessment or judgment that you made earlier. Well, actually the consistency ratio is the one that we will use, and as mentioned previously, it is easily performed by computer programs. So we limit ourselves to estimate several things only until like yeah, we will see it here is in the comparisons. So first, this one is the matrix that we already generated previously. Okay, and we have the priority for each criteria here, and we will use this as a weight in each column. So this one, okay, put it here, criteria weight. Okay, basically just plot it there, and then we need to multiply each of the first column value to sorry, first row value. Okay, first row value uh, to the rest of the um, uh, to the rest of the rows. Okay, for example, here you multiply this with this with this with this, and then you will get a new column for the cost row, comfort and safety here. Also do the same for the next here. Yeah, you will get next here weighted columns, weighted rows actually here, and here the last one you get this one. Okay, and then you need to sum all of the row. Okay, sum of the row here, this plus this one will be equal to this. So you get the weighted columns on the third column. Okay, and okay, yeah, you need to add the values. Okay, based on this one, you will have this one, like the last one, calculated weighted sum column at the end of the day. From this weighted sum columns, you put back the priority of each weight here. This is for cost, comfort, safety, and you need to divide this weighted sum divided by the priority. For example, for the cost, 2.0 divided by 0.669, it will be equals 3.01. This will divided by this, equal to this divided. Okay, and then these three value, in order to get the lambda max, as you remember, the consistency index is lambda max minus n. So you need to sum it first. Okay, this total equals 9.021, and then you divide it by these total numbers divided by number of criteria that you have. This will be equals to the lambda max. Okay, findings the lambda max is the critical part, because the lambda max will be determine the consistency index. As you can see here, the formulation is that this 3.007 minus 3 is the number of the criteria divided by 3 minus 1. It equals to 0.004. This is your consistency index. However, to calculate the consistency ratio, okay, consistency ratio, you need to divide with the random index parameters, in which, as we mentioned earlier, we will have for each number of criteria, let's say 3, start from 3, because less than 3 we don't need to check the consistency. The number is 0.58 here, so we use this 0.04 divided by 0.58, so it equals to 0.006. What does it mean? It means that the consistency is less than 0.01, CR is less than 0.01, which means that the adjustments that we made is consistent, and then we can use for the decision making and continue to the next step of AHP. Okay, the next step is after we have the wake, as you can see the illustration here. Now for achieving the goal of selecting car, we have the wake of each priority here, here, here. Okay, and now based on this wake, we will derive each of the alternative. We will derive the local priority. It means that for each cost, comfort, and safety, which one is preferable among these two cars. Okay, the next steps for this, for conducting this, will consist, deriving local priority for alternatives with respect to its criterion. So we need to determine that the priority of alternative with respect of each criteria. For this purpose, we will do a pairwise comparison. Again, like comparing this comfort with comfort, cost with safety. However, this one will be make the comparison for car 1 and car 2. Okay, the alternative parts. Okay, and how do we compare this will be based on the criteria. Let's say in terms of cost, car 1 and car 2, which one is more important, something like that. Okay, so in a model with two alternatives, it is required to make only one comparison. Okay, because only two alternatives. So a model with three alternatives, okay, but let's say you have car 1, car 2, and car 3, you need to make three comparison. Yeah, alternative 1, alternative 2, car 1, car 2, car 2 and car 3, and car 1 and car 3, something like that, for each criterion and so on. So there will be as many alternative comparison metric as there are the criteria. So of course consistency must be checked if the number of pairwise compared is 3 or more. So it means that the same approach that we use to calculate consistency index for criteria should also be applied for the consistency index of the alternative comparison. Okay, now we are going to discuss the step of deriving local priorities or preference for each of the alternative. It means that it will be based on each criteria. Here we will do a pairwise comparison based on each criteria. Okay, for each alternative. So for example here, in terms of cost, we will compare car 1 and car 2. Which one is more preferable? Okay. So let's assume, okay, car 1 or car 2, for example. This example shown that car 1 is very strongly more important than car 2 because they put it here 7. Okay, then this one is 1 divided by 7 is equal to this one. So next, what we need to do is after this comparison is to have this priority, right? For each criteria, we will find the local priority in terms of those alternatives. So we will need to follow the same steps that we followed earlier, in which we need to first calculate the summation of the columns here. Yeah. Let me erase this first. Okay, so the sum of the column here is calculated by this summation. And then from table 3 to table 4, we create a normalization, in which means that each of these cells will be divided by the sum of the column. Okay, 7 divided by 8, 1 divided by 8, and then you get this one. Okay, for example, this one 1 divided by 1.143, it should be equal this. And then this one 7 divided by 8 equal to 0.8. Okay, this will be the the normalizations. Okay, and then we will calculate, okay, the priority, which is this one for each alternative. For example, car1 first is this plus this divided by 2. So basically the average is equal 0.875. And then this one's this, okay. And then after you get the priority, you put back this priority to the original table. So you will get this one, okay. So basically you do the same things for the comfort, for the safety, okay. Let's say for the comfort now, okay. Comfort, you compare car 1 and car 2. Oh, car 2 is how to say more strongly more comfortable than car 1. So this one is 1 divided by 5, this one is 5, okay. And then you need to calculate the normalized value of this one. So you sum this one, 1 plus 5, 6, 0.2 plus 1, 1.2, and then you divide this divided by this equal to this one. Do it the same for all of the color, for all of the cells, and then you will get the normalized value here, right? Then you need to calculate the priority for each criteria. So this will be this plus this equal to this, okay, divided by 2 equals to this, so because it's the same value, okay. The same one you need to do it for safety. For example, car 1 or car 2 is extremely more safety than car 1, so you put 9 here, 1 divided by 9 here, and then you do the normalization, calculate the summation here, okay, do the normalization here, and put the average here, and you get the priority. Finally, all of this priority, okay, you summarize it into one tables, okay. So you will see the general picture here, where car 1 in terms of cost the priority is 0.875, in terms of comfort 0.167, safety 0.1. It means what? It means that, oh, the bigger the value here, it means that, oh, car 1 is in terms of cost is higher than compared to car 2. Car 1, however, in terms of comfort is less than car 2. Car 1 also in terms of safety is less than car 1. This is based on the judgment of this example. Okay, based on the final local priority that we have previously, now we can derive the overall priority or synthesis of the model. So let's try to illustrate it first. Based on the first step, we have this one, right? The weight of the criteria. And then the second step, we have this part, the local priority of each alternative based on each criteria. Here we go. For example, for cost, in terms of cost, car 1 is 0.875, car 2 is 0.125. In terms of comfort, car 1 is this one, car 2 is this one. In terms of safety, car 1 is this, car 2 is this. Okay. And then now we need to take the consideration of weight. Okay. because this is only localized. Now we take consideration of the weight of each criteria to this value. Okay, so this is called the synthesis. Okay, so you need to calculate the overall priority for each car 1 and then car 2. Take example for car 1 first. Okay, car 1. Car 1, the overall priority will be like 0.875, yeah, because this one goes here, multiplied by the weight of the cost, 0.669, and then plus this one, 0.167 multiplied by 0.0x, plus the last one is this one, 0.1 multiplied by 0.24. This is the overall priority of the car 1, and you get this value. Okay. However, for car 2, you need to calculate the rest of it. 0.125 multiplied by this plus 0.833 multiplied by 0.08, 0.9 multiplied by 0.243. So then you can see that this will have the two different value for the importance. And how do we conclude this one? Based on the previous judgments, that the car 1 is more preferable with the overall priority is 0.624 based on this experiment. Okay, the last steps before making the final decision is that we can do the sensitivity analysis on the result that we already have. So why does it important to do sensitivity analysis? Well, basically it's like this. The overall priorities that we got from previous experiments is shown that it will be heavily influenced by the weight given to the respective criteria. For example, that in the table shown in the table 13 here is the original scenario that we have, which the weight of the cost is much higher than the other two. So that's why when we have the comparisons, the car 1 is somehow preferable to compare to the others car, because this very high weight for the cost criteria. Sometimes it is important to do sensitivity in analysis, or in this case we can also call it what if analysis, to see how the final result, so the result that we already have previously, would have changed if the criteria would have been different. So what if the criteria different, then what the final result would be. So this process is called sensitivity analysis, and it's constituted the 5th step of our AHP methods. So sensitivity analysis allows us to understand how robust is our original decision, and what are the drivers of these new decisions that might generate it. So for example, which criteria influence the original results, and this is an important part of the process. And in general, normally final decision will be made after we conduct the sensitivity analysis. So to perform sensitivity analysis, it is necessary to make changes to the weight of the criterions. See how they change the overall priorities of the alternatives. To exemplify this, we will analyze the following scenario from our previous example. First, when all the criteria is the same, how it gonna change the results. Number 2, or B, what weight is needed for the cost criterion to lead to a tie in an overall priority alternative. So okay, we know that we prioritize cost for this one. However, if you reduce the weight of the cost at which value, at which weight, the score will be high. Okay. So in summary, we can see here, table 13 is the original scenario where the car 1 is the preferable decision. In table 2, where we have the same amount of weight for each criteria, so it's equal, you can see that there is changing here. Car 2 will be more preferable if you put the same weight. However, if you want to see what is the alternative, what is the value of weight that will give somewhat equals, we cannot get exactly equals, yeah, just somewhat equal. It's when you give the weight of cost is 0.5. Okay, next about making final decision. So once you make all of those previous step has been complete, it is now possible to make decisions. This constitutes the last step in AHP analysis. For this, it is necessary to compare the overall priority obtained and whether the difference are large enough to make it clear in your choice. And it is also necessary to analyze the result of the sensitivity analysis. From previous analysis, the sensitivity analysis, we can express our final recommendation. For example, if the importance of the cost is more than 50%, the overall important criteria in the decisions will prefer to the car one. However, if it is less than 50% for the cost weight, if you prefer cost less than 50%, then car 2 will be the best decision. Okay, although the AHP calculation can be done using, let's say, Excel spreadsheet or simple spreadsheet, and then the apparent of the software package such as expert choice, and then there is super decision or decision lens, it can help you make the AHP mathematical calculation very easy. So there is these three software that we can recommend here. You can try to download and install and see the feature of it. The last part of this presentation is actually we want to make a demo video. However, this video is already too long. Therefore, we will create another videos regarding how to use the software. But for now, if you are already interested on experimenting on the software, you can, let's say, try once using a software called Super Decisions. This is the link to how to install and download it. Next, in terms of building AHP model using Super Decisions, you can try see this link from these videos. Okay, so basically what we are discussing earlier is only a small part of the books that we use as the main reference. In this book, there is several chapters yet to be discussed. I hope I will have time later to discuss this with you. But for now, if you are interested on more intermediate level of using AHP, you can see this topic which is discussed on this book that we already discussed, the first 1, 2, 3 and 1, 2, 3, 4 chapter earlier. Okay, well, I think that's all. Thank you very much, everyone.